Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation with variable question. So we are given a second order linear differential equation and we are going to solve our problem using variation of parameters method. So let's get going. Problem: solve x minus 1 into d square minus xd plus 1 into y equal to x minus 1 whole square by the method of variation of parameters. So here we are given a differential equation with variable quotients and also this is of order 2, right? Given differential equation, x minus 1 into d square minus xd plus 1 into y equal to x minus 1 whole square, right? Now we can write this as x minus 1 d square y minus x dy plus y equal to x minus 1 whole square. We know that d is a differential operator whose independent variable is x, then d square will be d square by dx square, right? So we'll write d square y as d square y by dx square minus x into dy by dx plus y equal to x minus 1 whole square, right? Now let's write this equation in standard form. In order to write the equation in standard form, we have to make the quotient of d square y by dx square to unity. So we'll divide both sides of the equation with x minus 1 or multiply both sides of the equation with 1 by x minus 1. I'll just divide both sides of the equation with this x minus 1. Then I'll get d square y by dx square minus x by x minus 1 into dy by dx plus 1 by x minus 1 into y equal to x minus 1 whole square by x minus 1, right? Then d square y by dx square minus of x by x minus 1 into dy by dx plus 1 by x minus 1 into y equal to here 1 x minus 1 gets cancelled, so we'll get x minus 1, right? Consider it as equation number 1, which is in standard form. Now we need to find the general solution of this equation, which is given by y equal to yc plus yp, right? Now we'll find yc using inspection method. Okay, I'll show it. So let's now write the homogeneous equation of equation 1. Its homogeneous equation is d square y by dx square minus of x by x minus 1 into dy by dx plus 1 by x minus 1 into y equal to 0, right? Consider it as equation 2, or just compare equation 1 with the standard form equation and write p, q, r, okay? Or you can compare this equation with standard form of second order linear differential equation and you can write p and q, okay? So here we are going to find yc, which is a solution of homogeneous equation or part of complementary function of 1, okay? Now I'll just compare 1 with the standard form d square y by dx square plus p into dy by dx plus q into y equal to r, because I need r. Okay, for that purpose I am going to compare with this equation 1, or you can just compare 2 with this and write p and q. Okay, since I need r, so I'll compare 1 with this equation. So we have p equal to minus of x by x minus 1, q equal to 1 by x minus 1, and r equal to x minus 1, right? Or if you compare 2 with d square y by dx square plus p into dy by dx plus q into y equal to 0, you'll get p and q. Minus of x by x minus 1, q equal to 1 by x minus 1, right? So we are having p equal to minus x by x minus 1 and q equal to 1 by x minus 1 and r equal to 1 x minus 1. Just compare p and q. In p you are having minus x by x minus 1 and q equal to 1 by x minus 1, right? So if I try 1 plus p plus q, I'll get 1 minus x by x minus 1 plus 1 by x minus 1, which is equals to x minus 1 minus x plus 1 by x minus 1. Plus x minus x gets cancelled, minus 1 plus 1 gets cancelled, and is equals to 0 by x minus 1, which is equals to 0, right? Therefore 1 plus p plus q equal to 0. We know that if 1 plus p plus q equal to 0, then y equal to e power x is the part of CF of 1, right? Therefore y equal to e power x is the part of CF of 1, or y equal to e power x is the solution of the homogeneous equation of 1. We have named it as 2, right? Okay, and first case, this is the first case, and second one, if you take p plus qx, you'll get minus x by x minus 1 plus q 1 by x minus 1 into x. This is equals to minus x by x minus 1 plus x by x minus 1, right? Which gives minus x, or this 2 gets cancelled, we'll get 0, right? Therefore p plus qx equals to 0. Since we know that if p plus qx equals to 0, then y equal to x is the part of CF of 1, right? Therefore y equal to x is the part of CF of 1, or y equal to x is the solution of homogeneous equation of 1, which is equation 2, right? So y equal to e power x and y equal to x is the solutions, are these two are the solutions of equation 2, right? Since y equal to e power x and y equal to x are the solutions of equation 2, therefore y equal to yc equal to c1 into one solution e power x plus c2 into another solution x is the solution of equation 2. Okay, or we got yc, Therefore, yc equals to c1 e power x plus c2x. If you don't have variable coefficients, you'll get, or the equation will be of the form f of d into y equals to q of x. There we'll find yc using the auxiliary equation f of m equals to 0, right? We'll find two roots and we'll write yc using that two roots. But in our case, we are having variable coefficients x, so we need to follow this process because our equation is not of f of d into y equal to some q of x form. Okay. So we are having yc equals to c1 e power x plus c2x, right? Just compare it with yc equals to c1u plus c2v. So by comparing these two, we'll get u equal to e power x and v equal to x, right? Now let particular integral be yp equal to au plus bv. It is nothing but yp equal to a into e power x plus b into x. Okay, now we need to find a and b using the variation of parameters method. We'll be having two formulas, a equal to minus vr by uv1 minus vu1 and b equal to integral ur by uv1 minus vu1 into dx, right? So firstly we'll find uv1 minus vu1 because it exists in both sides of the formula in the denominator. So remember that the denominator must be non-zero. Okay, let's now find uv1 minus vu1. You're having u equal to e power x. If u equal to e power x, u1 is given by du by dx, that is derivative of e power x with respect to x, which is e power x, right? u1 is e power x and we are having v equal to x. v1 is derivative of v with respect to x, which is equals to derivative of x with respect to x. Derivative of x with respect to x is 1. So v1 is 1. Now let's find this. We'll have e power x into 1 minus x into u1 e power x, which is equals to e power x minus x into e power x. Now take e power x common from these two terms. We'll get e power x times 1 minus x. Therefore uv1 minus vu1 equal to e power x into 1 minus x. Now we can find a and b. A is given by integral minus vr by uv1 minus vu1 into dx. This equals to integral minus v x into r x minus 1 by uv1 minus vu1 is e power x into 1 minus x. Now just multiply these two terms with minus, then we'll get minus x plus 1, right? So we'll write minus x plus 1 as 1 minus x. Now cancel 1 minus x from the numerator and the denominator. This is equals to integral x by e power x into dx, right? We'll write x by e power x as x into 1 by e power x into dx, which is equals to integral x into 1 by e power x is e power minus x into dx. Okay. Let's now find integral x e power minus x dx using integration by parts formula. integral u dv equal to uv minus integral v du. See, in the integrand you are having the product of polynomial function into exponential function. So we'll take the polynomial function as u and the remaining part as v. We are having u equal to x and dv equal to e power minus x into dx, right? Now here differentiate on both sides with respect to x, then you'll get derivative of u with respect to x equal to derivative of x with respect to x is 1, right? So from du by dx equals to 1, you'll get du equals to dx. Okay, now integrate on both sides. We'll get v equal to e power minus x by minus 1, which is minus e power minus x, right? We'll get v equal to minus e power minus x and u is x, right? So now applying this formula, we'll get integral u, which is x into dv, which is e power minus x into dx, equal to u into v, x into minus, we'll write clearly, integral u into dv equal to u into v into, okay, uv minus integral v into du is dx. This is equals to minus x e power minus x minus into minus plus integral e power minus x dx, right? This is equals to minus x e power minus x plus integral e power minus x dx is e power minus x by minus 1, which is equals to minus x e power minus x minus e power minus x. So integral x e power minus x dx is minus x e power minus x minus e power minus x. We got a equal to minus x e power minus x minus e power minus x, or we can take minus e power minus x common from these two terms. We'll get minus e power minus x times x plus 1. Therefore a equal to minus e power minus x into x plus 1. Let's now find b. B is given by integral ur by ue1 minus vu1 into dx. This is equals to integral u e power x into r x minus 1 by uv1 minus vu1 e power x times 1 minus x into dx. This is equals to integral. Now what I'll do is I'll take minus into minus, which is plus. Okay, so I'll take 1 minus outside the integral and 1 minus inside the integral. Now I'll multiply these two terms with minus, then I'll get minus integral. Here e power x gets cancelled, okay? Then you'll get minus x. Just multiply these two terms with minus, you'll get minus x, minus into minus plus 1 by 1 minus x into dx, which is equals to minus integral. You can write minus x plus 1 as 1 minus x, right? In the denominator you are having 1 minus x into dx. This 1 minus x gets cancelled from the numerator and the denominator. This becomes minus integral dx, which is equals to minus x. Therefore, b equal to minus x. See, we got a and b. Let's now write yp. yp equal to a e power x plus bx, right? Where a is minus e power minus x into x plus 1 into e power x plus b minus x into x, which is equals to minus e power minus x into e power x into x plus 1 plus into minus minus x into x square. Now we can write e power minus x as 1 by e power x. We'll get 1 by e power x into e power x into x plus 1 minus x square. Here e power x gets cancelled and this is equals to minus of x plus 1 minus x square, which is equals to minus x minus 1 minus x square. We can write it as minus x square minus x minus 1. Now we can just take minus common from all the three terms and we'll get minus of x square plus x plus 1, which is our required yp. Therefore, yp equal to minus of x square plus x plus 1. We are having, or we got yp and yc. Let's now write the general solution using y equal to yc plus yp. Therefore, the general solution of the given equation or equation 1 is given by y equal to yc plus yp. Then y equal to yc is c1 e power x plus c2x and yp is minus of x square plus x plus 1. This completes the problem. So we have seen a problem from variation of parameters in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.